Hey, quick question. Ever wonder why your soda fizzes when you open or why lemon juice makes your face crunch up? That's acid and bases doing their thing. Hi everyone, welcome to our presentation about the Brønsted-Lowry theory of acids and bases. Today, we are going to explain this concept in a way that's simple and easy to understand. We will cover who discovered the theory, how it works, and why is it important in chemistry. The main focus of this theory is the transfer of protons or H plus ions between substances.
Yes, instead of just memorizing definitions, we want to help you understand how acids and bases interact. The Brønsted-Lowry theory is really interesting because it explains reactions that happen not only in water but also in many other situations in chemistry.
Acids and bases are all around us. We find them in the food we eat, in the cleaning products, and even in the human body. Over time, scientists have developed different definitions of acids and bases, but some reactions could not be explained by the older theories like the Arrhenius definition.
That's why the Brønsted-Lowry theory is so important. It gives a more general explanation by focusing on how protons are given and received. This helps us understand reactions in water and even in other environments like gases or biological systems.
The Brønsted-Lowry theory was proposed in 1923 by two chemists, Johannes Brønsted from Denmark and Thomas Lowry from England. What's fascinating is that they work independently, but both came up with the same idea about acids and bases at almost the same time.
They discovered that acids are substances that donate protons, and bases are substances that accept protons. This finding gave a more general understanding of acid-base reactions and helped chemists explain reactions that older theories could not.
Brønsted and Lowry theory noticed that many reactions did not fit the Arrhenius theory because it only worked in water. They realized that protons were the key to understanding acids and bases.
This discovery allowed scientists to see a wider range of chemical reactions. They also introduced the idea of conjugate acid-base pairs, showing that when an acid donates a proton, it becomes a base, and when a base accepts a proton, it becomes an acid.
According to the Brønsted-Lowry theory, an acid is any substance that donates a proton, while a base is any substance that accepts a proton.
Unlike the Arrhenius theory, which only applies to water, this definition works in different environments and explains a lot of chemical behavior. The key is remembering. Acids give, bases take.
In a Brønsted-Lowry theory acid-base reaction, the acid gives a proton to the base.
The base accepts the proton and may form a new substance. This always creates a conjugate acid-base pair, showing how acids and bases are related. You can imagine it like passing a ball. The acid throws it and the base catches it.
In this example, it will explain how the concept works. So, in the reaction between HCl and NH3, HCl acts as the acid because it donates a proton, while NH3 acts as the base because it accepts the proton. When the NH3 gains the proton, it forms NH4 negative, which is called the conjugate acid, and when HCl loses the proton, it forms Cl negative, the conjugate base. This reaction clearly demonstrates the Brønsted-Lowry theory concept of proton transfer, where acids give protons and bases receive them. It also shows the formation of conjugate acid-base pairs, and importantly, this type of reaction can occur outside of water, making the theory more general than the older Arrhenius definition. The Brønsted theory is very important because it explains reactions that happen outside water, including gases, biological systems, and industry.
It provides a broader understanding of chemical interactions. Chemists can predict how substances will behave and react, which is very useful in many areas of science.
To sum it up, the Brønsted theory focuses on the transfer of protons. An acid is a proton donor and a base is a proton acceptor.
Remember, acid gives proton, base receives proton. This theory is still a key concept in modern chemistry. Thank you for watching.